This meeting is being recorded.
Okay, can someone summarize what we have discussed in the yesterday class, please?
I can do that. In yesterday's class, we discussed about impact of automation in networking, which is a streamlined process, and scalability enhancement. Then we discussed about controller-based configuration. And then we discussed about centralized controller, which includes management, scalability, agility, and better network visibility. Then we discussed about software-defined architecture, which is APIC, Application Policy Infrastructure Controller. In that, we discussed about CVP Cloud Vision Portal. Then we discussed about underlay and overlay. And at last, we discussed about northbound API and southbound API.
Okay, yeah, that is correct. So in the yesterday class, we discussed about impact of automation on network management. We talked about how we can get the improvement of operational efficiency and how we can use it for reducing manual errors, and also how we can do like streamlining tasks, how we can improve the accuracy, how we can increase the efficiency and the agility and scalability, right? We discussed about the impact. Also, we compared a traditional network with a controller-based architecture. So by doing the controller-based architecture, what are the major advantages that we're going to get, like management, scalability, visibility, and agility. We discussed about how the centralized controller can manage multiple networks like switches, routers, and how can a single point of management used for entire network, which can provide the view, right? Like Varun said, using an Epic controller for Cisco or CVP for Arista, we have different vendors out there. They do using different products. If you talk about Palo Alto firewall, Palo Alto does use Panorama, right? So it really depends on each classified vendor, and then they do it differently. But the underlying concept stays the same. How we can manage many devices from a single point of view, right? So that is one biggest advantage, and also how we can do the mass updates to the devices, how we can provide efficient monitoring of the devices, so they all can be done using the centralized controller. And then we discussed about separating the control plane versus data plane. Like as you guys know, the control plane is like the brain of the system, and the data plane is like for the forwarding the packets, basically the mix of the device. So using that, we know that a software-defined architecture will be used to separate the control plane and data plane. And to avoid failing of the control plane, we will put multiple controller devices in a cluster. So even though if you have one control plane device failed, we have other two devices as a backup running as the copy. So that is, they call it as cluster, which will share the database of all the routes and all the control actions that can be defined on all the controllers. And then we discussed about underlay architecture and overlay architecture. We discussed about a physical network that is connecting the devices, which will be the underlying connectivity, that will be the underlay. And a virtual network that is running on top of the physical network, like a VPN, that can be considered as an overlay network, where it can provide network segmentation. It can also support like overlay connectivity, like you sitting in a remote site, you can connect to the data center with an overlay connectivity by having a security in play, like a VPN. And also we discussed about the fabric architecture. Fabric is nothing but like having a high scalable, flexible network, which can be interconnected in a way that it can, have multiple flows of the data. If one flow go down, you have multiple other paths. We discussed about spine leaf architecture, how we can have the spines in full mesh to the leaves, and how the overlay, like leaf to leaf, there will be an overlay tunnel that can be used in the east-west traffic communication than the northbound, southbound, right? We discussed about having a tunnel that is built between the leaves. It can be called as a VXLAN tunnel or EVPN tunnel. We're not going to that detail much because it is not part of the syllabus. But you can form the tunnels inside the fabric so that the east-west traffic communication will be faster. And then we discussed about APIs. API is basically application programming interface. We discussed about how we can use higher level management systems talking to a lower level management systems is called southbound. If it's in the reverse, like lower level talking to the higher level is called northbound. I think we gave an example like ordering in like a site, right? So you log into a site or purchasing a movie ticket, right? You go to the site and then you will purchase a ticket. You will go to the counter. That will be the API call from the application to the counter, and from the counter to the actual person in the theater where he will be verifying your ticket. So this workflow, when the person in the theater talking to the counter guy, that will be a northbound, but the application talking to the counter guy is a southbound. So that's the workflow we discussed yesterday, and how we can, how it will be easier to organize them. So that will create more flexibility because the API calls are different in each direction. So that is about yesterday class and the summary. Any questions before we start today class? Okay, today we're going to talk about the DNS center. DNS center is also a centralized management server, but that is for the campus network. It is not for the data center. If it's for the data center, we will use Epic controllers like we discussed yesterday. So if you want to understand a campus network versus a data center, think about like this. Campus network is nothing but a university building or a hospital or a what I can say, a remote office. They can all be called as campus networks, like a building of like 100 users, 1,000 users, or like multiple buildings that are interconnected. That can be called as a campus network. Whereas a data center is like having like thousands of servers where the streaming of data is done. For example, you go to YouTube and you play a video. In that case, that video is stored in the data center of YouTube. So you are seeing something, you are making a call to a data center and you're streaming something out of the data center. But let's say you are going to an hospital network, like you are sitting in the hospital and connecting to Wi-Fi in the hospital. So you are using a campus network there. Similarly, if you're in a university, your university has like 4 or 5 buildings and they will be connecting using the campus switches, like core distribution access layer. That will be a campus network. So a site with the users, that can be called as a campus network. But a site with servers, like streaming data, saving the databases, saving the applications, hosting the applications. So those are called data centers. Like for example, Facebook, right? You go to Facebook and then you access a profile, right? But that data center, Facebook is hosting all of the data in a data center. But let's say you are in a site, like a university site, and you are accessing the university Wi-Fi, or you are accessing university wired connection. So that can be called as a campus network, compared to you sitting remote site and then using services from the data center. So data center is like a collection of servers where lots and lots of data is there, and the data is being used by the end users from remote sites. In that case, the data centers are used. But in the same site, if you are sitting in the office and then you are accessing the office network, that can be called as a campus network. So here we'll be talking about managing the campus network using the DNA center, Cisco DNA center. Is it clear?
Yes, sir.
Okay, good. Let me share my screen. So if you have like so let's say this is building 1, building 2, building 3, building 4. So there will be users sitting in this building in their desks, and they will be connected to the local switches in that. The wired will be connected to the switch. These are called access layer switches, right? Access switches where the users will be connected. And these are the distribution switches, which will be used to connect between the buildings, right? So for access layer, if the person sitting in the building 1 wants to talk to building 2, they can go to the distribution switch. They can go to the layer 3, where this is the core, layer 3. And then they will be coming back and then going to this. Let's use a different color. So they can come back and then reach. So the core will be doing the layer 2 switching between them. But in a traditional network, the control plane is sitting on the each device. So every device has to look at it in its control plane to how to route the packet between building 1 to building 2. So access layer switch will send the traffic to the data port, and the data will be sent to the core, and the core will sending it back to the building 2, right? So this is a traditional control plane sitting on the each device. But in a DNS center, these all devices will be managed by the DNS center. So these are just doing the forwarding of the packets, right? But actual control plane decision will be done by the DNS center. That is centralized control plane where the control plane sits here, and the routing decisions will be announced by here, talking to the each device. For example, the access point will, the access layer switch will talk to the control DNS center to how to route the traffic between the devices. So every control plane of all devices will be hosted here, and from the decision will be made to talk between the buildings or to talk between the devices, right? So the DNS center holds the control plane. So this is in the campus network. Similarly, if it's a data center, it's using by the epic controllers like we discussed yesterday. So that holds the control plane. So DNS center is like an centralized platform for managing and automating the Cisco campus network, right? It can provide a single point of management for the entire network. It can provide, you can also have like access points. You can also have like printers. You can also have like secure devices like firewalls. They all can be managed by the DNS center, which is centralized management point. So from a DNS center, we can do like real-time metrics, like if an interface go down, the DNS center will automatically send the trap and get the response back. So you can have a centralized view of each device in the DNS center, and it can also give the real-time visibility, like what is the packet rate of each interface, or it can also give like performance of threads, performance of the traffic. What is the throughput that is going on inside the fabric? What device is talking to what? It can give you a visibility into it. It can provide visibility into what being changed. For example, if a user logged into the switch and then shut down the port, so it can give the visibility into the actions being taken by the fabric. So DNS center is like a solution that can provide capability to automate your network as well. For example, if you wanted to upgrade all of these devices, you can push the code directly to the devices and you can automatically upgrade them. You don't have to manually log into each device. The DNS center can push the code to the software to each device and you can update them. If you're working in a corporate network, it will make your life easy because you can log into the controller and then you can select the devices that you want to upgrade and you can push the code from there, right? Instead of you manually log into each device and then doing the upgrade. For example, let's say there is a new site that is building on the, new building that is coming to the network. So there is a new building. So there is to provision new switches, right? So in a traditional network, you have to manually log into each switch and then configure. But in the DNS center, there is a concept called template. So all the configuration will be using the template. You can reuse what's configuration on these devices, building 1, building 2. You can just change the IP addresses and then you can push the same configuration to these devices based on the template based. So you don't have to worry about reconfiguring everything. So this, as a network engineer, it will save your time because template is already there. You just change few settings. It's like, if you have a script, you can just change the names of the script, right? And you can reuse the script. Similar case, the template is used like a standard configuration that can be reused based on the need. You don't have to build the template again from the scratch, right? You have some base configuration, you can adjust a few things and you can push them to the new devices. That will help you to the onboard of the new devices. So the DNS center can help us to do that. So again, so if we talk about the advantages of the DNS center, it can give you the centralized management. It can help you to do the automation. It can help you into the visibility and insights of the fabric, like traffic rates, throughputs, and all of that. And also it can, if your network is this big, you can have a centralized controller, right? From a DNS center perspective, you can manage, you can see the whole network diagrams, you can see the whole network throughput, everything can be managed from a centralized controller point of view. So that way, you know what device is connected to where, right? This can give you a physical view of your network and also logical connectivity of your network. Those are the advantages of the DNS center. It is no different than what we discussed yesterday, but DNS center is a concept that is involved in the certification because it is used by Cisco to manage the campus networks, not the data centers. Any questions?
I have a small question, sir. So when you told templates, templates are the one, like what if we don't have, are they pre-designed or we use them from the previous designs?
Cisco will provide you some of the basic templates. You can use them, or you can build your custom templates based on the need. But if you go to GitLab or GitHub, if you go to the DNA documentation, you can already have some templates out there. But when you use the Cisco services at the beginning, when you're procuring a new DNS center, they will help you on building the templates at the basic premium level.
Okay, thank you, sir.
Any questions?
Is a DNS center only specific to Cisco, or there are other companies that manage DNS centers as well?
No, Cisco proprietary. Only Cisco uses it.
Oh, okay.
Cisco is like the big brother, right? 80% of the networking world uses Cisco. Other 20% will use other vendors. But Cisco is like the biggest of all brands.
Sir, I have a question too. Sorry, I think I'll be backtracking a little because I might not have understood the previous concept. So the DNS center, what you showed us, it looked like it can be used as a data center also, but I didn't understand that part. How it is specific for campus networks only.
Because the models it support will be utilized by the campus networks. For example, if you bring a Nexus 7K, that is a data center switch, that cannot be supported by the DNA center because it's a data center switch, not a campus switch. So the data center switches are like big beefy boxes that can carry the bigger load because they are carrying the load of the servers. But the users, on the other hand, will use a different set of switches like Cisco 9300 Catalyst switches. So those are supported by the DNA center. It is a compatibility issue between your switch that can be talked to the DNA center.
Okay, got it. So when it comes to data centers, will the software that is used, will it be similar to what you showed us here? Will it be similar to the DNA center only, but obviously at the price level?
Well, the software, the look and feel definitely changes. The Epic controller that I discussed has a bigger concept. For example, Epic controller is something called EPG, which is same as treating the device as a group. For example, they call a concept called bridge domain. The bridge domain is same as the VLAN concept. You know VLAN, right? We are separating the broadcast domain. In the data center, they call it as a bridge domain, which will separate broadcast domain into multiple smaller domains. Like a bridge domain is a layer 2 boundary. In the traditional networking, you call it as routing, where you point the route outside of your network, right? That can be done using a L3 out in the Epic controllers. So that is called L3 out, pointing a route outside your fabric. So the terminology changes, the look and feel changes, and the components changes in it. But what is common is the idea of managing the devices from a centralized control plane. The terminology changes, everything changes in the Epic controller. In the DNA center, similarly, it is differently called. Let's take a step back. The reason behind having two different products is to make money. So for example, if you talk about Honda has an economy car. It also has a Acura brand, which is the luxury car. Why is Honda making two different cars for two different users? Just to make more money. The data center people can afford more money. They will have a higher price point, which can have more features. In the similar way, how the cars are designing luxury cars versus the economy cars, Cisco also designed something for the data center from different use cases than an economy car like a DNA center. Is that clear?
Yes, sir. Got it.
Yeah, it really depends on the use case, right? For example, data center has a throughput of needed 100 gigabit per second, right? But do you imagine a user using 100 gigabit? It will cost 100K just to buy an interface, $100,000 just to buy an interface. Do you expect a user need that level of usage? I don't think so, because a user will hardly use 1 gig. I mean, a site of users, like 50 users may use 1 gig at a single point of time, right? We don't need 1 gig throughput for a user unless that user is like managing the whole data center metrics. We don't need that amount of data. Even though you download 100 movies, you don't need 1 gigabit per second, right? So a user will have lesser bandwidth utilization and needs. Similarly, a data center has different needs. For example, let's take YouTube, right? YouTube will need hundreds of gigabits per second because throughout the world, people are streaming the data and they need faster throughputs, right? The data center should be delivering the content to the user. That's why they need faster performances and faster switches. In those cases, we use data centers. And those need a different controller than an enterprise network, which needs a different controller. So it's like how you wanted to scale your network in different places.
Got it, sir. One last question. Sorry. So Cisco DNA centers will typically work for one specific IP range only or multiple IP ranges?
No, it can work on different IP ranges. Why will it work on only a specific? What is your question actually? I did not get the gist of it.
So I thought it might be one specific IP range because you told that L3 routing will be missing. So if that is missing, then will it? I don't know. Maybe I'm not understanding that part better. Without L3 routing, is it possible to
No, I never said it will be missing L3 route. Maybe you misunderstand my whole point. I said for one subnet to talk to other subnet, it has to pass through the core. So the routing decisions is usually made on the device itself. But in this case, the DNA center will do the routing decision for you instead of doing it at the switch level or the layer 3 router level.
Okay, got it.
Because we have a
sir.
centralized control plane that is sitting on the data center, not on the each device.
Okay, got it. Yeah.
Any questions? Okay, let's go to the next topic. The next topic will be the REST API. Yesterday we talked about APIs already, right? Northbound, southbound APIs, how they are different. Similarly, there is a concept called REST API. So we'll talk about the REST, right? So REST is nothing but representational state transfer. For example, this REST API is for building the web services and APIs. So a REST API will basically used for the websites. For example, you as a user, if you make a HTTP request, meaning like I going to a site, will meaning if I go to google.com, that means I'm making an HTTP call, right? Because I'm going to the browser, typing https://www.google.com. That means I'm making a HTTPS application call here, which means that I'm using a API in the background, which is called REST API call. So that is making a request to the server to get the data. In a TCP terminology, it is called TCP. We are sending a TCP SYN packet and waiting for the acknowledgement. If you're talking about a TCP terminology, right? But in the HTTP terminology, we are making an API request and waiting for the API response back. So that API in a website, in web servers is called REST API. So the REST API will have some of the key elements, right? So let's talk about those key elements. One is CRUD and the other one is HTTP verbs. The other one is the data encoding. So these are the key elements that can make a REST API call. So let's talk about the CRUD. CRUD is nothing but create and then read. And then update. And delete. Okay. So based on the CRUD, the API will allow, like for example, I can using the CRUD, I can do like creation of a record. For example, when I mean creation of a record, I mean to say, I can go into google.com and I can search for a query, right? I can do like, what is CCNA? So I'm creating an request there. So that is something called creating an record there. Similarly, reading the data. For example, if I'm getting the data output from the web server to the my PC. For example, if I make a call to who is the president of United States, I made a query and I'm reading the data from the actual server to the to my PC. So I'm reading the data and then updating. For example, if I'm making a change, for example, going to Facebook page and updating my profile, meaning I'm updating something on the web that is already there, I'm changing it. And if I'm deleting my profile, if I have a Facebook account that is already there on the website and I'm deleting that. So creating is something that you are building something new. Reading is just reading the content that is already there. Updating, you're changing something, and deleting is you're removing something, right? It's very simple concept. So similarly, the API also work on these functions. These are called operations. Using the API, we can make a create operation. We can do a read operation. We can do a delete operation, and we can also do an update operation. Just like on the website, you can do all of these things. These are called CRUD operations. and then HTTP verbs. So these are very similar to the CRUD operation, but they call it as a different terminology in terms of HTTP. These are called get, post, put, delete. So as you know, HTTP GET request is something like reading the data. I mean, you're sending a request. For example, if I go to let's say this is a PC and this is a web server. Entered HTTP google.com, right? So I'm sending an GET request, meaning entering this command is called GET request. Okay. And then getting the data back to me is called GET response. Right. So these are similar terminologies like on the CRUD operations we discussed, but these are having a different verbs, right? So are you guys following me?
Yes.
These are also called as like HTTP methods, right? So the GET method we are talking about is getting the data. It is used to retrieve the information from a specific site. So using the request, GET should only retrieve the data, but it should not affect any other data. So it will not change anything on the site. It will not make any changes to the site, but it will just request the data and you're getting a response. For example, if you go to google.com and you're sending a request, right? Meaning like who is the president of United States, it get a response back to you, but you're not changing something that is already there on the web. So this is called GET request and getting a response back. And the next thing is post. Post request is used to send the data to the server. For example, you are sitting on the PC and you are uploading a file to the internet. That is post. For example, you are sending an email with an attachment, right? So you are sending something to the, which is local on your machine, but you're sending that, you're uploading that file to the, for example, you are on a Facebook and you want to post something, right? You wanted to post your image in your feed or Instagram feed. You post your image, that is called posting. You're making a post call to update something on the web server. So that will call as post. And what is put? Put is something that is a little different. For example, from the PC, you are posting, you're putting something which is replacing the current content. For example, let's say you are using Wikipedia, right? So on the Wikipedia, let's say someone told CCNA means professional level, but you are making an update, CCNA means associate level. So you're putting something there which is updating the current information. You're changing something that is already there. That is called put. Put is nothing but altering the data that is already there. It will replace the current representation based on the uploaded content. So that is called put. And then delete. Delete, you already know that you are deleting something that is already there. For example, you already have an image on your website and you're trying to delete it. So that is called deleting. So get is retrieving the data, post is updating the data, put is altering the data, deleting is removing the data. That in terms of HTTP verbs. Questions? Okay. The next is data encoding. Data encoding is nothing but the language that is used by the API. So every human has a language, right? We all speak different languages, right? Similarly, the application also uses a language to talk between, like PC to web server. It is used a language. For example, it might use something called JSON or XML to represent the data. So these are like encoding languages, right? So this is the data structure to represent the resources in a format which can be easily transmitted and understood by different systems. So this is basically for providing and exchanging the data. When you go to http google.com, you are making an XML or JSON call between your web server. You don't know what language you used in the background, but the application is using an API call, and that API call will have a language that will be decided by the site and the browser that you are using. So they will use certain language to talk to your server. So this encoding format will be, specified in the header. For example, in the HTTP header, if you have a header, HTTP header, like this HTTPS will have a header, right? The header will have an encoding technique, like it could be a JSON or XML. Based on that, you can make that call. So it is basically what language we can use to make that API call. So overall, we can say like REST APIs are like a flexible way for the websites, which can be used over the internet or web. These are like standard things that are used at the application layer to talk between the sites. The reason why we are learning this is when we are trying to do automation, we can make the call from the DNA center to all the network devices using the JSON or XML format. So that's why we are learning these kind of things, because we wanted to automate our network programmability, right? So that if we are not willing to automate anything, there is no point of learning anything here on this site. There is no point of learning anything. But if you want to automate few things at the network layer, like managing the devices, upgrading the softwares, making the configuration easily from a centralized control plane, you need to have some sort of coding skills like JSON or XML. You need to understand JSON is easier because it uses key value pair, right? If you look into the JSON structure, it is very easy. It will be something like, name, interface. So this is called key value pair. So it is easy to understand and it is easy to use by network engineers because it is not complicated like C language or C++ or Java. It is not a complicated language. It is more of like user readable format. So that's why network engineers lean towards JSON because it is more user friendly and it's easy to understand as a network engineer. Many people come to networking because there is no coding, right? Many people choose networking career because there is no coding involved. That's why network engineers thought that let's make easy for every engineer who want to automate. They chose something called JSON and Ansible, right? Ansible is also something that is more JSON based. It is user friendly and it does not need high level coding skills. If you sit for a week, you can understand JSON pretty good, and you can write your own playbook. It is as simple as that. So that's why people thought that using JSON with Ansible, along with Python, right? Python is the base of Ansible and other things. Any questions?
Sir, can you once briefly tell me again the difference between CRUD and HTTP verbs?
Well, we are not talking about the verb differences here, right? Those are just the terminologies, how we use for the HTTP and HTTP. The HTTP, how they are talking to the sites. The CRUD is how we are calling it as an operation. We can call it as create, read, update, and delete operations. That way, it is easy to understand as a human reader what we are talking, those operations. But as an application, it uses something else like get, post, put, and delete. The application uses those verbs.
Okay, sir.
Any questions?
Yeah, I'm not able to picturize how these take place? As I mean, when a CRUD operation is in process, can a HTTP verb also be in the same process, or they just exist? I mean, separately. I mean, how does that work actually? I mean, I'm not even able to frame my question properly right now.
No, I think it's a valid question. Those are how we call it as an operation, but they both are same. If we talk about CRUD operation, that we are talking in terms of API. But if you're talking about the HTTP verbs, we are calling it as get, post, put, and delete. So CRUD is basically, these are talking in terms of API functionality. These are talking in the HTTP functionality, but the method is same. The creation of a record, reading a content, updating and deleting is when we are talking about the API based functionality. This is to understand from a human perspective. But from an application perspective, like HTTP application itself, it is something like get, post, put, and delete. There are codes for it. For example, get is a request, and if the data is successful, it gets a response of 200. That is a good response. So application uses these kind of responses to make sure that it got a valid response. So if you open a website, meaning like you are sending a GET request, right? And then you're getting a response back with 200. Okay, so this is an HTTP terminology. The same terminology can be called as read operation, where you're opening a website and you're getting the content back. But this is in terms of API. This is in terms of HTTP verb. The operations are same, but how we are talking in terms of API versus the HTTP is different. Those are not two separate things.
Okay. Also, could you explain REST again? I mean, putting aside CRUD and HTTP verbs, I mean, what exactly does the REST call do? I mean, or does it contain the CRUD and HTTP verbs in its whole entirety? I mean,
yeah, REST is nothing but an API call. It contains the CRUD and HTTP verbs, correct?
Sir, let me try to summarize it if I'm understanding it. It's a standard interface that is used to interact between web servers. And this is what is going on when I'm sending a request. So if I type in google.com, then I'm just doing the read function, right?
Yeah, you're doing a read function in terms of API. You're doing a get function in terms of HTTP.
Got it. And post will be create, put will be update, and delete is delete.
Correct.
Okay, got it, sir. Clear. Thank you so much.
Any questions? So we have different tools to make this function working. To automate, there are different management tools to automate this functionality. Like for example, if there are like 10 devices, okay, or let's say there are 3 devices to make it simple, and you have let's say you have a system, okay, and you wanted to send the code to all of these devices in a single shot. Let's say you wanted to create a VLAN 10 on these 3 devices from a single system, right? So you can use this management platform so that you can send the code to all of the devices, right? We talked about having a centralized controller. So this is a centralized system or controller. Similarly, for the automation, there are different tools that can automate this functionality. So there are 3 major ones that we can discuss here. One is Puppet. One is Chef. Third one is Ansible. So why is Ansible so popular? Mean Ansible does not need any software that need to be installed on the device. From the system perspective, it does not need a specific software to be installed on the actual network device. The system will automatically use a functionality called SSH. So using the SSH only, it can make the automation work. From a system, it will automatically log into multiple devices using the SSH. But other things like Puppet and Chef, we need to install a software on the device, so the system will communicate with these two devices. That's why Puppet and Chef are not so popular, or not so used in any of the networks. But Ansible is very much used. 99.99% is used Ansible because it uses an existing functionality called SSH. If a user wants to log into the device, he will use SSH. Similarly, Ansible uses SSH to automatically log into the device. So that's why it's more popular and very user friendly. Okay, that's why Ansible is so popular. But let's talk about the Puppet and Chef as well. So Puppet is like I can call Puppet is a configuration management tool, like I discussed, right? It can provide a specific language, like a specific console for managing the infrastructure, but it needs a software like a package installation that can be done on the device. So Puppet will be used by the user or the administrator, where they can define the infrastructure using the service management, or they can use a configuration file management from a centralized state. For example, if I have Puppet as a tool, it can send the data to the list of devices. Right? But it will be used only when it have the software or package installed on these devices. Right? So similarly, Chef will use something called cookbooks. Chef will provide the same automation using the cookbooks. So Chef is like a recipe. It is like a recipe approach for the configuration. So you have to create a recipe inside the Chef. You have to create a recipe. And inside that recipe, you will define the steps. And you will have that recipe step-by-step configuration, and it will use a tool with that recipe, and that recipe can be posted to these devices using a software on the device, Chef software on the device. So, but you have something called a recipe. It is something called as a language here, a declarative language. Okay. Whereas the Ansible is agentless. As I mentioned, Ansible does not have any agent. It doesn't need any agent to talk to the device directly. So you will create something called a playbook. Okay. Playbook is nothing but like a recipe, right? It's called something called playbook. Inside the playbook, you will have certain tasks that you create. Tasks. And you can use this playbook to push to the device directly to these devices, but it will use SSH functionality without having any of the agent running on the device. So think about like this: if I have 1,000 devices, I don't have to run agents on these 1,000 devices. I don't have to manually install the agent on all of these devices, right? So I can simply use SSH playbook, Ansible playbook that can be pushed to all of these devices simply using SSH. So I can create a playbook. Inside the playbook, I can define a list of all the devices, and I can create a task, and I can use the task to push to all the devices. That will be easy, and that structure will be in the JSON format. Okay, and Ansible, as I mentioned, it will be human readable, and it can provide like a centralized management place where we can run all these playbooks. I mean, you can do it manually from your system as well by doing an SSH functionality, but can also do something called Ansible Tower. Tower is like an GUI platform, like a software where you can run all of these SSH functions. So Ansible is like a software that can be run like a GUI platform that can run all these playbooks. You can execute these playbooks from the Ansible Tower. Or if your environment is so small, you can execute these playbooks directly from your CLI. Just like, executing a playbook from your PC that will assist to all of these devices. Instead of you manually doing it, it will take care of the functionality for you. Any questions? Because we don't use Puppet and Chef, Cisco did not focus more into them because it is not really a use case scenario used in 99% companies. They focused only on the Ansible and the notation in Ansible using JSON, right? That's why we as a network engineers don't touch recipes or cookbooks. That is general Chef. The server teams does it. Puppet is used by other deployment engineers who will be deploying, an agent on the servers that can be used by Puppet. Those are the automation techniques used by the server teams, not the network teams. Network teams mostly use Ansible because easy to manage, human readable. We don't have to do any extra work to build Ansible in our network. We can simply use SSH functionality, so we don't have to do any extra configuration on the switch side. Any questions? I know it is a lot of theory, guys. Application layer is something that we as network engineers don't use every day. But if you are a network automation engineer, you have to understand these topics because you are trying to automate a network. That's when you need to understand what is a REST API call is. You need to understand what is an API call is. You need to understand how the JSON structure look like. You need to understand a little bit on, how we write an XML or how we write a JSON like that, because you're trying to automate something from a centralized control plane. That is discussed in more into the CCNA DevOps side. But this is just more into the CCNA at the route switch, or which will be routing to the N core, which is the enterprise core, right? In this topic, they had only like 1% of it. But if you're trying to go to DevOps side, then you will touch more automation, how we use all of these platforms in more detail. But in our syllabus, we just touch it because we rarely use it I mean, I don't know how the industry turns in couple of years or maybe 5 years now. We might be doing more automation, right? It really depends on how the industry trends are going. People might move into AWS more, and we might be running into AWS, like building VPCs, building transit gateways, applying security groups. That is a different concept. Or people might be moving more into the automation, where we might be learning more into HTTP application, HTTP operations, or we might move into data center more. We might be learning Epic controllers more. It really depends on the kind of network, right? So there are a few networks where you will not even touch automation at all. They will just do the manual process, like building HTTP spanning tree, building VLANs, trunking the VLANs, assigning the routing to it, building OSP of EIGRP, like that. So it depends on what job you are landing into. Okay. Any questions before I go to Jason? Let me see what's the time. Okay, 10:02. I think we can stop it here. We can leave the floor for any questions. But let me see. Let's do a summary. Okay. Monica, can you tell me what is a DNS entries?
It supports and models with campus networks. It will make routing decisions, and it enables management of the inter-campus networks.
Yeah, so basically DNS entry is a software-defined platform that can manage the campus networks of Cisco. It is a single point of management for entire network. Like you can manage your switches, routers, access points, and other devices on Cisco, right? It can provide streamlining of your tasks using templates. It can give you real-time visibility. It can give you like logs faster. You can deploy devices faster using the templates as well. So yeah, that is correct. Okay. Dilip, can you tell me what is a REST API?
Representation state transfer,
Okay, what is it is used for?
like building the web servers in the API.
Yeah, when we are communicating with the websites or web servers, then the REST API calls are used. Basically, API call is make a connection between PC to the web application, right? So just we are making an request and waiting for the response back in terms of HTTP, right? Okay.
Yeah, we have the key elements like the CURD and the HTTP verb and the data encoding. And in the CURD, we can see the create, read, update, and the delete. Basically, the CURD means creation of the record on the website. HTTP verb means reading the data. And coming to the data encoding, it's a language used by API, I think.
Small correction. CRUD means it can create, read, update, and delete, but it is used in terms of API. But HTTP verb also do the same function, but we are talking in terms of HTTP. It's like same meaning, two different languages, right? In English, we can call it as come here, right? In Hindi, we can call it as like aao, either aao, right? So it's the same, but we are talking in two different languages. Similarly, CRUD means we are talking in terms of API functionality. HTTP verb means we are talking about the application functionality. Both are doing the same function here. Okay. Okay, that is good. Hari, can you tell me what is a GET request in HTTP?
So when the PC sends an request to the web server, it is yeah. So it's sending a get request, and the web server sending back the response is sending back the get response.
Yeah, we are sending the request to the web server and waiting for the response back. That is basically a get. We are trying to read the data that is already there. Yeah. Okay. So, Sriram, can you tell me what are the data encoding types? Sriram?
Yes, sir.
Yeah. What are the data encoding types?
What, sir?
What are the data encoding types?
Like binary to text encoding, UTF, MD5, hash. So
Dude,
these
are
are
you listening to the class?
yeah.
But your answer doesn't sound like that.
Oh. So these are the types of encoding, right, sir?
All right, next one. Sorry. Varun, can you tell me what are the data encoding types?
Yeah, Puppet, Chef, and Ansible. Puppet and Chef are used by the server teams, and Ansible is used by the network teams.
Yeah. Anyone can tell me what are data encoding types?
We discussed about JSON, XML.
Yeah. Yeah, JSON and XML are the data encoding types. Those are the formats that are used by the systems to talk between them. So usually the encoding format is typically specified in the HTTP header. Based on that, we will know whether we are using JSON or XML. Usually
Yes,
REST APIs will use
JSON.
JSON format because it is easy to
It is.
understand for everyone.
Yeah, it is. Yeah, it
Thank
is
you.
human readable.
Yep. Okay, thank you. Shiva, can you tell me what are different management mechanisms that we use for automation? What are different tools that we use for automation?
When you say tools, they could be softwares too, right?
Yeah.
Yeah, that is Ansible, Puppet, Chef.
Okay. What is the most commonly used and why do we use it most
So,
commonly?
so Ansible is more preferred in most cases because of the user-friendly nature of it, and majorly because it doesn't require any installation on its network devices for it to be used. Like you said, it can be used via SSH through the system, but doesn't require any installation. But while Puppet and Chef are other softwares or tools, they require installation on network devices, which makes it a little odd and a little difficult for everyone to adapt to.
Yeah, that is correct. So using the Ansible is most preferred because it is easy to create a playbook by the user without having anything to install on the device itself. And it is easy to manage because it uses JSON, which is human readable format. So that's why JSON is simple, human readable syntax. Along with it does not need any agent. It is an agentless, easy to approach system. That's why Ansible is most popularly used. Okay. That's all the questions I got. If you have any questions, you are feel free to ask. And if you don't have any questions, thank you for joining today. And thank you for answering the questions.
Thank you, sir. Good night.